Welcome to the Benu Networks Operations Manager overview and demonstration. In this demonstration, we're going to show how easy it is to configure and launch the Benu Networks Cloud Native BNG into service. Fundamentally, the Operations Manager is responsible for network configuration and launch, service enablement, and the collection and display of operational and performance data once the network is in service. We'll demonstrate how the Operations Manager framework shown here, through the use of open APIs, industry standard protocols, real-time data collection, and automation tools, can speed deployment, replicate success, and reduce errors. You'll see and hear us touch on a number of key components. For automation, we'll talk about Kubernetes and the use of Helm charts. We'll talk about the use of deployment files and associated configuration files, which can be kept in a repository to be reused or modified for future use. We'll talk about how the use of industry standard protocols and open interfaces throughout our system make it adaptable to future changes or additions. And with our use of open APIs, how we easily integrate to northbound systems. Through the use and collection of real-time data and metrics, we provide the operator the valuable operational and performance information they require to run the network and to deliver the highest level of service possible to their customers.
Hello and welcome to our demonstration of the Operations Manager. Let's log into the portal and get started. Once logged in, we see a list of clusters that are managed by this operations portal. Here we can see the status of the all control plane. All the clusters is green, which means it is okay. Let's take a look at one. In this cluster, we see that we have only one deployment, which is called Boston BNG. And under this deployment, we have 3 user planes and 1 control plane. And on the right side here, we have its lifetime, and on the left, we have its status. Let's say we want to expand the service and we want to launch 2 more user planes, 3 more user planes in this cluster. We will show you how easy that is, and we will come back to investigate the operation statistics available from a running system. Selecting the launch button here, we are taken to an input screen, and as you can see here, launching a BNG into service requires only 4 inputs here. First is the Kubernetes namespace, a release name, a Kubernetes chart, and a deployment file. Let's start with the namespace. I'm going to use default namespace for this example, and the release name I'm going to keep the same as Boston BNG because I'm just going to bring up 2 more user planes here. Let's provide path to the chart and path to the deployment file. Again, it's only 4 pieces of information needed to launch 2 more user planes. Providing the 4 inputs listed here and clicking the launch, we will initiate the deployment. While this is processing, we will show you details behind the 4 inputs required. And let's talk about the Kubernetes cluster. Kubernetes is a container orchestration system for automating software deployment, scaling, and management. And the Helm chart is nothing but configurable templates that contain the resource definition necessary to run an application in a Kubernetes cluster. Kubernetes uses the Helm chart in a manner similar to the way Linux uses package managers, and the deployment file is nothing but a YAML file that contains specific information to configure and launch control planes and user plane sections. So here you can see we have a control plane details and the user plane details. In the control plane section, we have few options available, such as enabling or disabling high availability mode, providing a path to a configuration file repository where we store startup configurations for the control plane. Then we can allocate some virtual CPUs and memory for the control plane. And for the user plane, we have number of instances that we would like to bring up in total. In this example, I have 5 because I have 3 already running and I want to bring up 2 more. And then we have configuration file repository for the user plane. The repository for startup configuration file, which specifies the configuration of a wide variety of features, including quality of service, HQoS, CGNAT, access control list, and various of routing features or any number of supported capabilities. Each user plane included can use the same default configuration, simplifying the rollout of a large number of user planes. As you can see, the deployment file and associated control and user plane configuration files have the information needed to launch and prepare the network to provide services. Equally important is the configuration needed to onboard residential or business subscribers. Taking network built on PON as an example, it contains ONUs and OLTs, and they connect to a BNG over VLAN at a layer 2. To allow connection to an OLT, VLAN ranges are assigned to the user planes in the startup configuration file. Let's look at the example here. We have 3 user planes running, and we have Boston BNG user plane 1, Boston user plane 2, and Boston user plane 3. And we have subscriber groups where we define service VLAN and customer VLANs here for user plane 1, and the same for user plane 2 and 3. Once this is done, when the ONU and OLT come online and communicate with this user plane over a VLAN in that defined range, it can pass messages to the BNG so the subscribers can be authenticated and provided service. As you can see, the combination of Helm charts and information contained in the deployment file and associated configuration files allows the service provider to automate nearly all functions of bringing a cloud-native BNG and subscribers into service. These items are really key components underpinning automation. It is important to know that the deployment files and configuration files are pre-built and can be stored in the repository to be used, reused, or modified to launch new nodes or to even launch a completely new network. In this manner, deployments can be automated, duplicated, and operator errors can be eliminated. With that as a baseline overview, let's take a look at the BNG service we launched earlier and some of the statistics available from the active control planes. Let's click on the system test cluster and get into the details of the running deployment. Here we can see a control plane page details. Here we see some quick overview about memory and CPU usage, its active uptime, total number of sessions across all user planes, active pod IP, and the build that we are running right now. At the center page here we have chart with subscriber statistics, IPOE and PPOE, and we have debug tab where we can take a look at the control plane logs. Let's get back to details. At the bottom of the page we can see a list of the user planes that are associated with the control plane. We can see that we have 3 control planes that are already in service and have some subscribers onboarded. And at the bottom of the page we can see the subscriber redundancy list that we seen before in the startup configuration file. And there are 2 user planes that we just brought up and they don't have any subscribers yet. Let's take a look at the user plane. In the user plane page we can see some details similar like on the control plane. We have its uptime, total number of sessions only on this control plane, only on this user plane, its host IP where this user plane is running on, and the chart with subscribers, IPOE and PPPoE. Aside from just subscriber statistics, we can take a look at the throughput statistics here. We can see throughput per interface, total throughput, and throughput transmitted and received, as again per interface. Aside from just the graphs, we can take a look at the debug page where we see system logs of the user plane and the data plane containers. Let's get back to details. At the bottom of the page, we can see some interface statistics, and we can see a list of interfaces connected here right now up top. We can see that we have only 2 interfaces, its status, state of the interface, and the speed. And in the center of the page we can see some downstream and upstream latency metrics as well as the DNS packet latency. We have total bytes and packets processed counter, and we have counter of active devices, TCP flows created and reset. As you have seen from this demonstration, the Operation Manager tremendously simplifies the deployment and configuration of a BNG. This includes both the initial deployment and configuration, more commonly known as day 1 operations, as well as any changes, more commonly known as Day 2. From a small single-node BNG to a very large geographically dispersed multi-cluster deployment, or anywhere in between, all can be operated from a single pane of glass. Thank you.